everyone, welcome to the course on signal processing. This is lecture 3 and in this lecture we will see what are LTI system. So in our last lecture we have seen that the properties of a system, some of the properties are the causality, linearity, time invariance, stability. So we are fetching two properties now, the linearity and the time invariance. So the linearity is if a system follows the principle of superposition, it consists of homogeneity and additivity. If both are followed, then the system is said to be linear, otherwise the system is non-linear. Similarly, the time invariance means the time shift in the input signal result in the identical time shift in the output signal. So it is said to be time invariance. Or if we have shifted the input signal by a factor of 5 and the output by a factor of 3, then it is time variant. So first we will see what is the impulse response. So response is nothing but the output. Response is nothing but the output of the system. Now what is impulse response? We are aware that what is the definition for impulse. This is the impulse signals. We have seen in the subject signal system that signals are of, let us say, the impulse signal, the step signal, ramp signal and the parabolic signals. So these four type of signals generally we are encountered in the DSP or in the signal systems. And if we are utilizing here the impulse signals, means if we are treating this signal as the input to a system, to a LTI system, then we can say that the response is called as impulse response. Means when the input is applied to the system and the input is an impulse type, then the response of the system is known as impulse response, and we can denote the impulse response as Hn or Ht depending upon whether it is a continuous time or a discrete time. So if the input to the system is a time shifted version of delta n, means delta n is the impulse signal, the output is also the time shifted. These are the properties of the impulse signal, means if there is a shifting in the impulse signal, definitely there will be a shifting in the output signal also. The response, the output response or the impulse response will also be shifted by the same factor. So this is a small proof here that Fxn is some alpha times of del of n minus k, means the signal delta n is bit shifted by a factor of k and which is applied to a LTI system, then the output is something yn equals to alpha h of n minus k. So mathematically also we can calculate the response of the system if the input and impulse responses are known, then we can calculate the response of the system with the help of this particular formula, which is yn equals to summation k equals to minus infinite to infinite hk x of n minus k, and mathematically this representation is for convolution operator. Convolution operator. So convolution operator, this is very helpful in determining the response of the system. Means if we are aware how this convolution works, then definitely we can calculate, we can compute the response of the system. So here we have the summation. So it is also known as convolution summation. And if we are having the continuous time signals, continuous time system, then we can have the convolution integral. So this is the impulse response. Likewise, we can give the definition for step response also. What is step response now? If the input to any system is a unit step signal un, the definition for un is the value is 0 for all n less than 0 and the value is 1 for all n greater than equal to 0. This is the definition for unit step signal. So if this type of signal is applied to a LTI system, the response is called as unit step response. So, we have the shifted version which is u of n minus k. So, what happened? We can say that for all n less than k, the value is 0, whereas for n greater than equal to k, the value is 1, and we have both the signals u of n and u of n minus 2. This is a shifted version of un, means the step signal is shifted by a factor of 2. Now, we have the relationship. We are aware that what is the relationship between impulse signal and the unit step. We can understand this. We have the impulse signal like this, and what is the unit step? If we have the shifted version of these impulse like this, and if we are adding all these signals, we are putting a summation on the impulse signal, then we are getting a signal which is called as unit step sequence. So, we can say that the first difference, this is called as the first difference, means un minus of un minus 1, this is nothing but equals to the del n. So, we are definitely going to utilize this concept, which is the relationship between the unit sample and the unit step sequence. Now, we will come back to the properties of the system. So, we will see how this linearity will work, how we can check the linearity and the time invariancy of the system. So, first we will start with the linearity. So, as I was telling you in the last lecture also, that if y1n and y2n, these are the responses, these are the output sequence to the arbitrarily input sequence x1 and x2. So, what happened? And after that we are performing the operation which is the processing on these signals. So, we are getting, this is called as a system, we have applied a system, a1 times of x1 plus a2 times of x2, we are applying a system, and if this is equal to this particular equation, then the system is said to be linear. We can understand this with the help of a small diagram here. If we have x1t or x1n, we have x2n, and if we are using here that a1 and a2, because we are aware that the linearity is basically, if a system is following the principle of superposition, then the linearity is verified, otherwise the system is said to be non-linear, and the principle of superposition consists of homogeneity and additivity. Homogeneity and additivity. So, homogeneity means if we are multiplying the input signal xn by a factor of a, and here we are multiplied by a factor of, let us say, a2, and after that we are performing the summation over here, and after that we are applying the system here. Generally we denote the system like this, and we are getting the response which is called as a1 x1n plus a2 x2n. Let us say we are assuming this as equation number 1. And second here is that first of all we are applying system directly to x1 and x2, means if we have x1n, we have x2n, and we are applying system first, and after that we are using the homogeneity a1, and here we are getting a2, and we are performing the subtraction. So, we are getting here is f, or a1 is constant, x1n plus a2 f x2n. So, if let us say if both the equations, equation 1, that is equation 1, and this is equation number 2. If both equations are same, then we can say the linearity is verified, because it is following both. Homogeneity is also verified and additive is also verified. So, the system is said to be linear, otherwise the system is non-linear. So, in some various type of numericals, we'll go for additivity first. If additivity is also not verified, means if out of these both properties, if any one property is also not verified, then we can say linearity is not verified, means the principle of superposition is not verified. So, we are having the first example. The example is quite easy here. We have A, which is a constant, n xn plus some constant b. Now, we are going to see whether this system is linear or non-linear. So, first step, how we can see? We have x1n plus x2n, means we have x1 signal, we have x2 signal, and we are applying the system directly. We can see this, means first of all we are performing this x1 or we are performing the equation number 1, means we are adding the input signals x1 and x2, and after that we are applying the function, we are applying the system. So, we are getting here is A. Now, what the system is performing here? The system is basically performing three things. First, it is multiplying the input signal by a factor of n, it is multiplying by a constant of A, and it is performing the addition of B. Means the system is performing three tasks. It is multiplied, the input is multiplied by a factor of n, it is further multiplied by a constant A, and some plus B is added. B is added to the input signal xn. So, we have applied the system directly to the addition of inputs, which is x1 plus x2. So, we are getting A times of n x1n plus x2n plus b. This is equation number 1. This is equation number 1. Now, we will apply system directly to x1n and x2n. So, if we will see what happen here is A times of n x1n plus b plus A times of n x2n plus b. This is equation number 2, right. Now, we will simplify this equation number 2. So, what we are getting here is we are getting A times of x1n plus n A x2n plus 2b. We are getting a constant which is 2b, but in equation number 1 we are getting only plus b. So, we can say that equation number 1 and equation number 2 both are unequal, both are not equal. So, we can say that the principle of superposition is not verified and the system is said to be non-linear. Again, with a condition. What is the condition? That b must not be 0. What happens if b is 0? If b is 0, so this is also 0, this is also 0, and we are getting a equation number 1 and equation number 2 both are same. So, the system is non-linear with a condition that b is a non-zero quantity. So, this is a process by which we can check the linearity of the system. Next, we are increasing the level. Let us say the y equals to e raised to power xn, or some equation we are getting, we are having which is e raised to power xn. So, how we can apply the linearity? So, first of all we will have x1n plus x2n, and we are applying the system directly to this addition of signals. So, we are getting e raised to power x1n plus x2n, which is nothing but e raised to power x1 dot e raised to power x2. Let us say this is equation number 1. Now, we will apply system directly to the signal x1n and x2n. So, we are getting here is e raised to power x1n plus e raised to power x2n, which is let us say equation number 2. And by seeing this both the equations 1 and 2, in first equation both are available in a product form, whereas in equation number 2 both are available in a summation form. So, we can say that again these two equations are not equal. If they are not equal, then we can say the principle of superposition is not verified and the system is said to be non-linear. Next, this is bit advanced type of problems based on the linearity, because by seeing this particular case, what the system is performing, which is quite important here. The system is basically averaging and the system is basically shifting the input signals. So, the system is performing two tasks here. It is basically shifting as well as it is performing the averaging of the signal. So, we are having y1n which is due to the input which is x1n, and we are getting y2n due to the input which is x2n. So, we have y1n and y2n. If we will add these signals, which is yn equals to y1n plus y2n, so we are getting, let us say, equation number, let us say 1. Now, if we are having the signals x1 plus x2 and after that we are applying system directly, so what we are getting here is, what we are getting? We can say that x1 plus x2 and we are performing the system x1n plus x2n. After that we are performing the system onto this. So, we are getting the same equation. The equation, the output will be same as that we are getting in the equation number 1. So, if both the equations are same, then we can conclude here that the system is said to be linear. Now, we have next yn equals to xn square. So, xn square, this is what the system is performing here. System is just squaring the input signals. So, yn we are getting x1n plus x2n and we have applied system. Now, we can open this and we are getting x1n square plus x2n square plus 2 times of x1n and x2n. So, this signal we are getting when we have x1n plus x2n and we have applied system directly. We are getting equation number 1. Now, what is equation number 2? Equation number 2 is, we have x1n, we will apply the system first, we have x2n, again we are applying the system and will perform the additivity operation. So, we are getting equation number 2 something like this, which is x1n square plus x2n square. So, we can clearly see that here equation 1 and equation 2, they are a bit different. This term is extra. So, we can say that the system is not following the principle of superposition. If the principle of superposition is not verified, then we can say the system is said to be non-linear. Now, we need to test again the linearity for some continuous time signals. So, they are quite easy, because we are aware that we have the signal which is xt and after that the system is performing the sine operation. It is performing the sine operation onto the input signal. So, again we will check both the conditions. First condition, when we have a1 times of x1 plus a2 times of x2 and we are applying the system onto that, we will be getting those signal. The equation is, let us say, x1 will give rise to y1, x2 will give rise to y2. So, we are getting a signal which is the addition of these two equations, which is 5 times of sine x1t plus 5 times of sine x2t. Now, so which is equation number 1. Now after that we are having x1, we are applying function directly to the signal. So what we are getting here is 5 times of sine a1 x1 plus a2 x2. Now we have to apply sine of a plus b or sine of c plus d. If we will open this, we are getting a equation number 2, and we can clearly see that equation number 1 and equation number 2 definitely they are different, and that is why the system is said to be non-linear. Yeah, we have some further examples. This type of signals we have already seen in the discrete time cases. So we are aware that we have two equations. In the first equation we are getting 7 times of a1 xt plus 5 plus 7 times of a2 xt plus 5, and we are getting the addition of those. So let us say equation number 1, and equation number 2 when we have x1 plus x2 and we are applying directly the system onto that. So both the equations will be having they are a bit different, the constant is bit different in both the equations, and definitely we can say that the system is said to be non-linear. So this question is quite easy to understand that the system is linear or not. Generally by seeing itself we say that y equal to mx plus c, and the system definitely is a linear system because y equal to mx plus c represents the equation of straight line. Now this is a bit different type of case. We have a differential equation, means we have the derivative of yt plus 10 times of yt plus 5 equals to xt. This type of problem is bit different. So how we can initiate, how we can check? We are first aware of the condition that this condition has to be satisfied for the linearity. So when we are having the signal x1, it will give rise to the output which is y1. So we have this equation. Next, when we have input x2, that means it will give rise to the output which is y2. So first we are getting the addition of these two equations by using the homogeneity. So a times of this one plus we are getting this b times, let us say this equation number 1. Now the equation number 2, we are having a1 times of y1t plus a times of y1t plus b times of y2t, and we are performing addition, and after that we are applying the system. So we are having here equation number 2. Now we can see that equation number 1 and equation number 2 they are bit different. How they are bit different? If we will open this, a1 times of y1t, we have d by dt, here we are having b multiplied by derivative of y2t plus 10 times of a y1t plus 10 times of b y2t plus 5a plus 5b, like this. So we can see equation 1 and equation number 2. So they are bit different. Now we can understand this. Here we have the t is also in a multiplication form. So we can directly perform the linearity that x1 will give rise to y1, x2 will give rise to y2. So we can make the equations, this equation and this equation, both the equations we can make, and if both the equations are same, we can see the linearity is verified. So I am just going to the next slide here, which is the how we can check the time invariance of the system. So time invariance is bit different as per the definition. a system is said to be time invariant if the time shift in the input signal results in the equal time shift in the output. That is why it is known as time invariant. Otherwise, the system is said to be time variant. How we can see? Again, we have two equations. We will be formulating two equations. We have xn input. We are applying a delay by a factor of k. We will see this is called as delay x of n minus k. I think at this particular stage, if we are aware of the z transform, so that z transform will be z raised to the power minus k and x of z. So, z raised to the power minus k basically represents a factor corresponding to a delay by a factor of k. So, first we are providing a delay, after that we are providing a system, we are applying a system onto that. We are getting equation number 1. Second equation is, first of all directly we will apply system onto the input signal xn, after that we are providing a delay. So, if this is equation number 2, so what happen? If both the equations, equation number 1 and equation number 2, if they are same, then we can say that the system is time invariant. And if both the equations, equation 1 and 2 are different, then we can say the system is time variant. Let us say yt equals to t times of xt. So, system is basically performing a multiplication by a factor of t. So, how we can see? First we have provided a delay x of t minus tau and we have applied a system. So, we are getting equation number 1, t times of x t minus tau. Next is we are applying system first. So, if we are applying system first, we are getting t of x of t like this, and after that we are applying now delay. So, what the delay is performing, wherever we have t, it will be replaced by t minus tau. So, t minus tau x of t minus tau. Let us say this is equation number 2, and we are going to check whether this equation number 2 and equation number 1, they are same or not, and it seems that both the equations are bit different, and if they are different, then it is called as time variant. Similarly, we have yn equals to x n square. Again we can see, we can clearly check this also, that the system is said to be time variant, because we are getting here is x of n square. If we will open this, we are getting x of n square minus 2nk minus k square. Let us say this is equation number 1, and equation number 2 will directly give us x of n square minus k. So, this is question number let us say the second case. The third case, which is quite easy, and system is basically 2 times of x n minus k here, and the second equation means first of all we have provided a delay x of n minus k and we are applying the system. So, this system is time invariant. The system is time invariant because both the equation number 1 and equation number 2, they are same. So, likewise we will check the time invariancy of the system, that will definitely helps in understanding the LTI systems. So, in the next lectures we will see the stability and the further properties of the systems. This question again, this is quite easy, we can understand this, it will give us the answer which is the time variant, sorry. These are the references. Thank you.